Okay, this is technically calculating velocity, which is very similar to rate of change. In fact, this specific one, we're going to go over average rate of change, not instantaneous. So, our average rate of change, we have this formula here. And it's modeled some pebble that's dropped from 80 meters up in the air. It eventually hits the ground. It exists from 0 to 4. So, obviously, he drops it at 0 seconds. At 4 seconds, it probably hits the ground, the lake, whatever it's hitting. They want us to calculate the velocity of this pebble between 1 second and 3 seconds. Okay. Now, what that means is our average, they want us to find the average rate of change. Average velocity or average rate of change is going to be equal to the change in S over the change in T. And what those stand for is change in position. We'll get into this after. Divided by your change in time. So change in time. Okay? So, when we look at this, we can calculate the change in position and the change in time. We're going to give this two coordinates. The first coordinate is at t1, so when time is 1, that is going to be our first x value when it's 1. That will also give us the height. If we plug 1 into this equation, we're going to get what? Anyone know? If I plug 1 into that equation, 1 squared is 1 times 5 is 1. What's 80 subtract 5? 75. So that is our position at 1 second, which will be our y value. Then we do the same thing for 3 seconds. Because at 3 seconds, that's our new time, which will be our x2. Here's our x1, y1. And at 3 seconds, 3 squared is 9. 9 times 5 is 45. 80 subtract 45 is 35. That's our y2. Okay? So I now have 4 points. And we know change in position. Well, our position is what our y values are. That's how high the pebble is above the ground. So a change in position is technically y2 subtract y1 divided by x2 subtract x1. Running out of time. Okay. Our y2 is 35. Our y1 is 75. Divided by x2. Well, that's our change in time. Well, that's from 3 seconds to 1 second. We'll then subtract our numbers. We'll get negative 40 over 2. The average rate of change between 1 and 10 seconds is our change in position, so that was meters, over our change in time, which is in seconds. So negative 20 meters per second. Whoops. Single page, entire page. There you go.